going to go through this very important unit, cost estimation and regression analysis. I think you all know that MDC builds on quantitative techniques. You find that most of the quantitative techniques are actually brought back into MDC. So there are certain techniques that you're going to be examined on just to test your understanding of those techniques. So in this unit we give the general principles and application of to estimating cost functions, because as a management accountant you should be able to estimate the costs of the company. You should be able to estimate revenues. You should be able to determine your profit or contribution in the future period, basing on the information that you have currently or basing on the information from the past. So one of those techniques that you're going to be examined on is regression analysis, where you'll be required to derive the regression equation, and in most cases the regression equation is used to estimate future performances, especially when it comes to costs and profits. You should be able to estimate future cost figures. Then of course the regression equation is divided into two. There is a case where we have a single independent variable and a single dependent variable. So that would be a linear regression. Where you have a single independent variable with a single dependent variable. Then it can also be expressed as a multi-regression equation, and here we shall be doing multi-regression analysis, where you have several independent variables causing change in a single dependent variable. Then of course you have all looked at the cost functions. We have the variable cost function and the fixed cost function. Then we have factors that are supposed to be considered when using past data to estimate the cost functions, especially the seasonal variations in data. And then you'll be examined on the steps involved in estimating cost functions. Then you'll be tested on the cost estimation methods and the application, like the engineering method, the inspection of accounts method, the graphical method including this scatter graph method, the high-low method, the least squares method, which again is covered in number 1 here in part 1 of the unit. Then you should demonstrate a clear understanding of test of reliability, including the determination of coefficient, standard error, and then of course the standard error of the coefficient. Then finally, under this unit, you'll be examined on the learning curve theory, including the learning curve effect and its application, plus the experience curve and its application. So our discussion will be rotating around this. And to begin with our discussion, we shall begin by looking at the regression equation. Regression equation, which I will discuss together or in line with the least squares regression equation, or the least squares method. Right. So as I've mentioned, we shall begin with regression analysis. And of course, in this unit, we shall bring out the key definition of regression. We shall look at the regression coefficient. We shall look at the types of regression, curves of regression, and determining the regression equation y on x, which is the least squares regression equation. We shall also have the uses. We shall also discuss the uses of regression. So, what is regression? Regression is concerned with establishing the relationship between two or more variables, where one variable is dependent and the other variable is independent. It is the process of establishing the relationship between two or more variables where one variable is dependent and the other variable is independent. We have what we call the regression coefficient. The regression coefficient is a measure of the existence of some definite relationship between two or more variables. It's a measure of existence of some definite relationship between two or more variables. It ranges between -1 and +1, the two inclusive. So as you have seen in my presentation, in the initial presentation, I've mentioned that we can have a simple linear regression where we have a regression equation in which we have one independent variable and one outcome variable, which is the dependent variable. Now, the linear regression equation is given by y is equal to mx plus c, which all of you know, or alternatively you can use y is equal to a plus bx. So we shall be using the second one, the alternative, y is equal to a plus bx. We can also have what we call multiple linear regression. Multiple linear regression is an equation in which we have multiple independent variables with one outcome variable. So it is given by this equation here, and as you can see, we have one we have one dependent variable, okay, and multiple independent variables. Of course, here you'd see x and then x squared and x to the power 3 and so on. So that would be multiple linear regression. So to clearly understand the application, we should be able to clearly understand or examine the least squares equation y on x. So when we talk about least squares equation y on x, we are looking at a scenario where we have y on the vertical axis and then our x, sorry about that, we are looking at a scenario where we have y on the vertical axis and x on the horizontal axis. So that is the line y is equal to a plus bx. Highly applicable in management. Now, because of the fact that total cost is equal to fixed costs plus variable costs, you would appreciate the fact that the total cost curve is derived from the least squares regression line y on x, where the fixed cost is equal to the a and the variable cost is equal to the b. Okay, the fixed cost is equal to the a and the variable cost is equal to the b. So meaning that if you're talking about the total cost curve, then it will mean that you are looking at a scenario where our curve or our line is cutting the vertical axis at the value of the fixed cost, because we know that the fixed cost is a, which is the constant, and therefore that is the point at which the total cost curve will cut the vertical axis. So for us to be able to derive the total cost curve, we should be in position to get the value of the constants a and e and b. So the constants a and b are determined from these relations. The constants a and b are determined from these relations. We have our b and our a right there. So for me to get the least squares regression line y on x, I'll need to get the value of b and the value of a. So this is our exam type question that we are going to use to demonstrate the application of least squares regression. So I'm picking this one from December 2020, and it's question number 1. It's question number 1. I'll read through, then I'll work with someone to arrive at the solution. So the question goes that House Paints Limited, a family business producing undercoat paint, was established in the early 2000s by Professor Candy Caesar. This guy is a retired industrial chemist. The business enjoyed steady growth until 2014, when the ownership decided to restructure the governance system to solve the expansion challenges. In 2015, a decentralized organizational structure was introduced under which production and distribution functions were made autonomous profit centers. A 7-member board of directors was put in place with the responsibility of supervising the managing director. The board's manual allows each board member to serve a maximum of 5 years, although the renewal is on the discretion of the annual general meeting, which sits in the month of January every year. Apart from the functions relating to finance, the production and distribution, all other functions were centralized under the head office administration function. Production, distribution, and head office administration units are headed by the managers, who are in the direct charge of the supervisors. An independent internal auditor position who reports directly to the board was also created. So we are given a lot of information here regarding the structure, head of office, IT, and so on. The board's 5-year term ended on the 31st of December 2019, and the AGM resolved during their meeting in March 2020 to renew all the board members' second 5-year term, since the board streamlined the company's communication policy. The board chairman, in his appreciation message to the AGM on behalf of the board, committed to improve the company's profitability, performance, and staff capacity building. He assured the AGM that the 5-year business plan 2024 will be developed in-house without engaging external consultants, since majority of the finance staff are certified public accountants. See, so you are the ones, you are experts. He stated that measurement theory is going to be at the forefront of conducting the company's operational business. The company boasts of having the largest market share for its paint at low marketing costs due to its strategy of controlling the selling price within the distribution chain. The distribution manager provided the following data relating to undercoat paint for the year 2015-2019. So they give us figures for the sales volume, buckets in thousands, marketing costs, shillings, 15, 16, 17, 18, and 19. Distribution unit projected to incur a cost of 378.6 million and 392.43 million on marketing undercoat paint during the year 2020-2021 respectively. So these are now the projected, they are projecting to incur those marketing costs. You are one of the company's accountants, and your supervisor has instructed you to perform the following tasks to enable proper understanding of the 5-year business plan. I'm going to concentrate. I'm interested in this first one because our discussion is on the least squares method. So required advise the company's board on the expected percentage growth in sales volume for undercoat paint between 2020 and 2021. Use the least squares method. So they want you to determine the expected sales volume for 2020-2021. So how are you going to estimate the future? The information given to us is up to 2019. So 2020 and 2021 are future periods. We are assuming we are standing in 2019. So how are you able to see or to determine the future performance 2020-2021 if you're standing in 2019? So the only way you can do that is by using a technique, a forecasting technique. And one of the forecasting techniques you're going to be examined on is the least squares method. We have seen the formula for the least squares. So it means that we need figures for x and y that can satisfy this formula. We need figures for x and y that can satisfy the formula. So according to you, in the chart, I want you to tell me, what do you think is our x? What do you think is our y? What do you think is our x? What is our y? Let's start from there. What is our x? And what is our y? Let's begin from there. So advertising is x, as I can see in the chart, and then the sales are the y. Of course, this is reasonable. Why? Because we do believe that advertising will cause a change in the sales. So in most cases, x is the independent variable and y is the dependent variable. Perfect. So let us go to our question now. Let us go to our question. Back to our question. The figures we have are here. That's why this is very simple. Just this table is enough for us to get 8 marks. Can you imagine? Just this table is enough for us to get 8 marks. You can imagine. So this is our y and this is our x. I think my table is now ready. My table is ready. We are using, this is December 2020, question 1 part A. So using the least squares regression, using the least squares regression equation, y is equal to a plus bx, we are interested in xy, summation of x, summation of y, the n are the number of years, and then x squared. So definitely this table will come in handy. So here we shall indicate the year, and as you can see from the question, as you can see from our question, years are running from 2015, 2016, 2017, 2018, 2019. So those are the years. Those are the years we are interested in. Okay, so our table is ready for use. We have said that advertising is x and the sales are y, which is okay. Advertising is x, sales are y. So the advertising, if I got the question here, if I got the question, the advertising 2015, I can see 308. The sales, I can see 58.5. Then 2016 advertising, actually this is marketing costs. This is marketing costs. This one is marketing cost, which is the same thing, but let's use what we are given here. Marketing cost. Marketing cost, which is our x. So the marketing cost 2016, I see a figure of 320, whereas the sales we have 84.6. Then finally 2019 we have marketing cost of 330, sales of 103.5. So your work is now to get the x squared, xy. Let's first of all sum up the x. 308, 320, 335, 325, and 330. What do you get? 1618. Okay, 1618. Then let's sum up the y. Sum up the y. 449.2. Okay, so we can square the x. Kindly square the x. 308 squared. Okay. Let's go to the next one. Good. So let's get the total here. Mm. Okay, we shall have y. Let's go to xy. You multiply this and this, eh? 0.72. Good. The next one. Good. Go to the next one. Good. So let's total up. 146. 224. Okay. 146224. Okay. Basically, this is what we have from the part of B. Our n is 5. Summation of x is 146,224. Summation of x, this is summation of xy. So summation of x is 1618. Summation of y is 449.2. Then n is again 5 in the denominator. Then summation of x squared is 524014 minus summation of x, which is 1618 squared. So this simplifies the numerator to 4314.4 and the denominator to 2146, which comes to 2.01. Okay, 2.01. All right, so the next value is the value of a, and we need to determine the value of a. Since now we have got the value of b as 2.01, so from our table, summation of y is 449.2, n is 5, and then of course our b is 2.01 times summation of x, which we got from our table as 1618 divided by 5. So there are several ways of doing this, but if you follow this pattern here by working out this first and then you subtract this value, then you arrive at negative 560. So that becomes our a. And now if we move to our least squares equation, where we have a, I have put this negative. Actually, I'm doing it the other way around. If you look at what I have now, because it's a negative, I'll use y is equal to bx minus a. So where I have a b, I've put 2.01x minus the 560.6. So that becomes our least squares equation, and that definitely marks the end of the largest part of the work we are supposed to do. So the next part is on the application. As you can see from our question, the examiner wanted us to get the expected percentage growth in sales volume for undercoat paint between the years 2020 and 2021. So we begin by forecasting the sales or projecting the sales for 2020. Remember, we are standing in 2019. Remember, we are standing in 2019. So we shall project the sales for 2020 using our least squares equation. And then we shall also project the sales for 2021 using our least squares equation. So we are told from the equation that the company or the firm is planning to spend 378.68 million in 2020 on marketing costs, or in terms of marketing. So of course, marketing in our equation is represented by x. So in our equation, I replace where there is x, I replace with the projected marketing cost. And for 2020, I'm going to insert the 378.68 times 2.01 minus 560. The projected sales, as you can see on my screen, come to 540 buckets of paint. Then for the year 2021, the projected marketing cost is 392.43 million. So I replace in our least squares equation, in the place of x, the projected marketing cost of 392.43. So that gives me the projected sales of 228 180 buckets of paint. So the growth in sales between 2020 and 2021, looking at the performance in 2021 compared to 2020, I will subtract the buckets in 2020 from the buckets in 2021 divided by the number of units that we have sold in 2020. So that gives us a growth of 13.8%. And therefore, our analysis and interpretation shall say that the sales volume of the undercoat is anticipated to grow by 13.8% in the year 2021 as compared to the year 2020, or from the year 2020. So basically, this is how we use the least squares equation or regression analysis in management decision and control. So I congratulate you for having completed this technique. So next we are going to the next technique, as I have indicated in our introduction. I wish you all the best. See you in the next session. Thank you.